Yeah, the Hess's law of constant heat summation, also known as the Hess law. It was actually named after German Hess, a Swiss-born Russian scientist, and it was actually published in 1840. So the Hess's law, it states that the total enthalpy change during the complete course of chemical reaction is independent of the sequence of steps taken, right? And currently it is now understood as an expression of the fact that the enthalpy change of a chemical reaction, when we are saying the enthalpy change, we are just saying like the state of function is independent of whatever path the chemical reaction might have taken, right? So we know that according to the laws of thermodynamics, the enthalpy change in a system due to a reaction at constant pressure is equal to the heat absorbed or the negative of the heat released, which can be determined by calorimetric for many reactions. So we are using the Hess's law in enthalpy change, where the values are usually stated for reactions with the initial and the final temperatures and pressures. These initial and final temperatures, they do not change. So basically what we are saying is like the total enthalpy change is independent of whatever path that it can be taken. It can take a different route, a direct route or an indirect route, but the enthalpy change will always be what? Constant. So basically what I'm trying to say is like the Hess law can also be used to determine the overall enthalpy change required for a chemical reaction that can be divided into synthetic steps that are individually easier to characterize. So again, this also affords the complication of standard enthalpies of formations, which may be used to predict the enthalpy change in a complex synthesis, right? So the Hess law, it actually states that the change in enthalpy in a chemical reaction is the same irregardless of whether the reaction takes place in one step or in several steps. So basically that's what we call the Hess reaction. So it can also help us to calculate even if we are not actually performing experiments using those algebraic, like whereby we can say the enthalpy change is equals to the summation of the reactants, the summation of the products minus the summations of the of the reactants. So in other words, you can just say the chemical change takes place by several different routes, but then the enthalpy change is the same regardless of the route by which the chemical change occurs. So basically that's what Hess, the Russian Swiss-born, was trying to explain, right? So if we say this is not true, then we'll be violating the first law of thermodynamics. So basically that's what Hess was trying to explain, right? So we just have to know that the Hess law in chemistry, it allows the enthalpy change for a reaction to be calculated even when it cannot be measured directly, and this is actually accomplished by basic algebraic operations based on the chemical equations of the reaction using previously determined values for the enthalpy of formation. So the main formula is, put a triangle H, we say the summation of the coefficient of all products minus the summation of the coefficient of what? Of all reactants. So we are saying is the first sum of all products and the second of all reactants, and that's how we get what? The enthalpy change. So basically that's what the this law was trying to explain.